Now, for this question, we're going to solve those 5 equations for the theta in the range of from the 0 to the 2 pi, meaning that our answer all should be in radian because the theta given in the radian here. So first, let's look at the first example, A. For the question A, we need to convert this cos 2 theta in terms of cos theta because we have two types of angle, that is double angle and a single angle. To solve this equation, we need to change every angle into the single angle. We know the cos theta, that is a formula for cos 2 theta equals to 2 cos square theta minus 1. So here is the formula that I'm going to apply now. Change this cos 2 theta into 2 cos square theta minus 1 and equals to 5 cos theta plus 2. Then we simplify, we arrange it nicely. After that, we replace the A as a cos theta. We obtain this equation, then we factorize it. You have these two factor equals to 0, solve it. You will have A equals to negative 1 over 2 and A equals to 3. Okay, substitute back the A as a cos theta. We have a cos theta equals to negative 1 over 2 and a cos theta equals to 3. So we're going to solve for the cos theta equals to negative 1 over 2 first by finding its basic angle. The basic angle can be obtained by finding the arc cos of 1 over 2. You got 60 degrees. Then now we can have the diagram to locate our angle. By looking at the cos theta equals to negative 1 over 2, we can see the negative sign here. Means that our angle theta is fall at the second quadrant and the third quadrant. And now we need to mark down our basic angle over these two angles. And now you can start to measure your angle. The first theta is from the positive x-axis to the first line that we have drawn. That is 120. Taking 180 minus 60, you get 120. The range given by the question for the theta is from the 0 to 2 pi, means that it's from 0 degree to 360 degree. So now we can move, we can rotate another to produce another angle. That is taking the 180 plus 60, that will be 240 degree. So if we make another one full rotation, it will be exceed the 360 degree. So we will stop here, and now I'll convert this into the radian. 120 degree is a 2 pi over 3. And 240 degree will be the 4 pi over 3. Alright, and now we proceed to the next question. So we for this question, we say that there is no solution for this equation because cos theta maximum can reach until 1 and minimum is negative 1. Yeah, you can recall back to the graph of the y equals to cos theta. Alright, so cos theta equals to 3 will be no solution. We just ignore this. And the final answer, it should be only 2 answers. That will be 2 pi over 3 and 4 pi over 3. That's it. For this equation, I'm going to convert this tangent square plus 1 into the secant square. Alright, so I'll rewrite the equation. 4 sine square theta, 1 plus tangent square theta can be converted into the secant square theta. And the secant square theta is a 1 over cos square theta. Yeah, secant square is equals to 1 over cos. And now I'm going to multiply both sides by cos theta. I got a sine square theta multiplied by cos square theta equals to 1. So there are two types of trigo ratio into one equation. So I will convert either sine square theta in terms of cos or cos square theta in terms of sine. So here I choose to convert this cos square theta in terms of a sine. I got a 1 minus sine square theta, which is I'm applying the first identity. Okay, then we expand it. We get a 4 sine square theta minus 4 sine power of 4 theta equals to 1. Okay, arrange it nicely. I'm applying, I would like the a to become the sine square theta. Then my equation will become 4a squared minus 4a plus 1 equals to 0. Then I'll try to solve for the a first. Here I have a equals to 1 over 2 and a is your sine theta, right? So replace back the sine square theta equals to 1 over 2. So your sine theta will be positive negative 1 over 2. Alright, so now I'm going to solve for the two equation. First one is a sine theta is 1 over 2. Second equation, later on I'm going to solve it. That is negative 1 over 2. Firstly, get your basic angle. That is 45 degree and locate your angle. Since our sine theta equals to 1 over 2, having this positive sign here, now our angle is actually 4 at the first quadrant and the second quadrant. Okay, so this is your 45 degree and this is your 45 degree. You can get your theta now by rotating your angle from the positive x-axis, which are the first angle you got it 45 degree, and the second angle is 135. Okay, if you move another full rotation and reaching this line, you will have the angle which is more than 360, which is exceed the data which is allowed by the question. So we stop here. Then convert those angle in degree into the radian. I got a pi over 4 for the 45 degree and 3 pi over 4 for the 135 degree. Now we move to the second equation. Firstly, get the basic angle. When you get the basic angle, just ignore the negative here. You still will get 45 degrees, same as the equation just now. Now have your diagram to locate your angle. To locate your theta, you must look at the sign over here. That is the sine theta having the sign of negative. So your angle will be 4 at the third quadrant and the fourth quadrant, where your angle of the 45 will be somewhere here because it must be next to the x-axis. Now you can try to measure your angle, finding the theta by rotating your angle. This is the first angle we have, that is 225 degree, and the second angle is the 315 degree. And now I'm going to convert those angles into the radian. To solve this equation, looking at these two angles, there are two types of angle. We need to convert this into the single angle. Using the double angle formula for the tangent to theta, now I have this. And now I multiply both sides by 1 minus tangent square theta. We have this. And after that, the tangent theta, I will change into the sine over cos. So both terms containing the sine theta, right? I can factor out the sine theta. And in the bracket, I got it 14 over cos theta and minus 4. Sine theta being factored out, so I have a sine square theta over cos square theta. Alright, leave it the right hand side to be 0. And now you can see that I got the two equations can be formed. One is the sine theta equals to 0. Another one is 14 over cos theta minus 4. 1 minus sine square theta over cos square theta equals to 0. So here, later on, we're going to solve for this. Now, we try to simplify this equation first. I multiply both sides by cos square theta. I got a 14 cos theta minus 4 cos square theta. And now we simplify it. Okay, simplify the left hand side. At the same time, I divide the 14 and the 4 by 2 at both sides. Okay, so now I would like to change everything in terms of cos. Okay, in terms of cosine. Here will be 7 cos theta minus 2 cos square theta. And the 2 sine square theta converted into 1 minus cos square theta. And simplified it to arrange it in the quadratic form. This is the equation that I can get in quadratic form. And then I put the a as a cos theta. I got my equation become 4a squared minus 7a minus 2 equals to 0. Now we try to factorize it and solve it. So you have a equals to negative 1 over 4. Replace back the a as a cos theta. And you have a cos theta equals to negative 1 over 4. Or cos theta equals to 2. And for this equation, we're going to ignore it because there will be no solution. The maximum number, the maximum value for the cos theta is 1. So when it equals to the value more than 1, you can say that this equation has no solution. Now you've got the two equations to be considered. That is the cos theta equals to negative 1 over 4. And one equation is the sine theta equals to 0. So try to solve for this first. Now I'm going to use the graph of the sine theta to solve for the sine theta equals to 0. From the graph of the y equals to the sine theta, I have my sine theta having a y value equals to 0 at 3 points, which is this point and this point and this point. So my theta will be 0, pi, and 2 pi. That will be the three angle that we can accept, okay, for this equation. Now we move to the next equation, which is the cos theta equals to negative 1 over 4. I have to find the basic angle by finding the arc cos 1 over 4. The basic angle is a 75.52 degree by finding the arc cos of 1 over 4. And we have this diagram to locate our angle. The green line shows that I'm measuring the angle starting from the positive x-axis to the line that we draw. So I got two angles, that is the theta equals to 104.48 for the first angle. Second angle, I have a 255.52. After that, I'm going to convert them into the radian. I have this 1.82 radian and 4.46 radian. Now you can make conclusion for all your answers. You combine all your answers. That is the three answers from above. That is 0, pi, and 2 pi. Okay, 0, pi, and 2 pi. And the next two answer will be 1.82 radian and 4.46 radian. That's it. For this example, I got a cos 3 theta, yeah, plus cos theta equals to 0. We're going to solve for the theta from the 0 to 2 pi. So firstly, I will rewrite the cos 3 theta, cosine of 3 theta into the cos 2 theta plus theta. And after that, I use the compound angle formula to expand it. I got cos 2 theta, cos theta minus sine 2 theta, sine theta. And after that, again, apply the double angle formula to split the cos 2 theta into the single angle. We have a 2. I use the formula of 2 cos square theta minus 1 to represent the cos 2 theta. And then copy back the cos theta. For the sine 2 theta, I will convert it into the 2 sine theta cos theta. And this sine theta just follows through. Then after that, simplify it. I will simplify it, and the sine square theta over here, I will replace it by the 1 minus cos square theta because I wish to change every term in terms of cosine. And after I simplify, I got my cos 3 theta equals to 4 cos cube theta minus 3 cos theta. So I can insert this into the equation. So here the cos 3 theta will be replaced by 4 cosine cube theta minus 3 cos theta, and then this positive cos theta just copy down and equate to the right hand side 0. So simplify further. I have a 4 cos cube theta minus 2 cos theta equals to 0, and now I can just factor out the 2, alright, and cos theta, factor out the cos theta. I got the 2 cos square theta minus 1 equals to 0. So then I solve it. I got cos theta equals to 0 and cos square theta equals to 1 over 2. So here I'm going to solve for the cos theta for this equation. That will be 1 over positive negative 1 over third of 2. So here we got a 3 equation to be solved. That is cos theta equals to 0, cos theta equals to positive 1 over third 2, and cos theta equals to negative 1 over third 2. For the first equation, cos theta equals to 0, I'm going to use the graph of the y equals to cos theta to solve for this equation. So when the y equals to 0 at this point, okay, at this graph, I got the 2 points satisfy the equation. That is when the theta is equals to pi over 2 and also the 3 pi over 2. So these two angles are the solution of the cos theta equals to 0. Proceed to the next equation, cos theta equals to 1 over third 2. I will try to get the basic angle first, which is this is equals to 45 degree. And this is diagram, we are going to locate our angle of theta since the cos theta taking the sign of positive, right? So the theta will be 4 at the first quadrant and the fourth quadrant, and the 45 should be over here. Now we can start to measure your theta. To get your theta by rotating your angle starting from the positive x-axis. Your first angle is 45 degree. The second angle is 315 degree. And I'm going to convert the theta into the radian. 45 degree, that should be pi over 4. And 315 degree will be 7 pi over 4. For this third equation, again we got the basic angle is arc cos of 1 over third 2. That is equals to 45 degree. So locate your angle down. Since the cos taking the sign of negative, so we should put our angle theta at the second quadrant and the third quadrant, where this is the 45 degree. Locate your now you can get your theta by measuring your angle. Rotating from the positive x-axis, you got the first angle is 135, which is 180 minus 45, and the second angle is taking the 180 plus 45, that is 225 degree. Okay, then now convert this angle into the radian. For the 135, you got the 3 pi over 4 radian, and 225 degree, you have 5 pi over 4. So now you are going to unite all the answers together. So you got 6 angles to be accepted as your final answer. That is pi over 4, pi over 2, 3 pi over 4, 3 pi over 2, 5 pi over 4, and 7 pi over 4. I'll try to arrange the angle from the smallest angle to the biggest angle. So this example F, right, is going to apply the double angle formula to split this into the single angle, and the same thing for the cosine 2 theta. So I suggest that the cosine 2 theta you can either change into the 1 minus 2 sine square theta or 2 cos square theta minus 1. Alright, so Okay, either this one, 1 minus 2 sine square theta, or you can change it into the 2 cos square theta minus 1. Either one will do. And the sine 2 theta, you're going to convert it into the 2 sine theta cos theta. And later on, you're going to move all the term to one side and then you factor out the like term, okay, the common factor. Then you solve for the equation. Remember, your answer must not exceed 0 to 2 pi, yeah? And your final answer should be in the radian. Alright, so here I provide you the answer. Here will be the answer of this question, so you can try this question. Alright, refer back to the example that I showed you just now, okay, and then this as your exercise. Yeah, the answer is 0.48 radian, 2.05, 3.161 radian, and 5.19 radian. So here is another example. Given that the secant x minus 5 tangent x equals to 3 cos x, we need to show this statement, this equation, into this quadratic equation, and hence solve this equation. If this is equivalent to this quadratic equation, means that we can solve this quadratic equation is the same as we solve the secant minus 5 tangent equals to 3 cos. Alright, and then the x mustn't be exceed from this range, that is 0 to 360 degree. Starting from this equation, you can see that this equation is not containing any sign. Yeah? Any term could involve this sign. So I would like to change all this into the either cos or sine first. So secant change into the 1 over cos, and then tangent change into the sine over cos. Okay, and the 3 cos x just remain as a cos x. Then after that, all the terms I will try to multiply by cos x, so that I can omit the cos x at the denominator here. Once the first term multiplied by cos x, I got 1. I got 1 for the first term, and the second term I have a 5 sine x, and this at the right side I got a 3 cos square x. So in order to change everything in terms of sine, I'm going to change this cos square x into 1 minus sine square x. Yeah, okay, this will be 1 minus sine square x. So now you can see that I almost have it as a quadratic equation. So now we just need to arrange it nicely. After we have simplified, I'm putting the sine square as a leading term, okay, followed by sine and followed by constant, and leave the right side to be 0. Now I have proven this statement. Okay, I have showed that this equation can be converted into this quadratic equation. Yeah. After that, I would like to solve it, because one question asked me to solve for this equation. Okay, so it's the same as I solved this quadratic equation. So let the a to be the sine x, then my quadratic equation in the trigo form will become 3a squared minus 5a minus 2 equals to 0. Now we need to factorize, and now I have a equals to -1 over 3 and a equals to 2. Since the a is a sine x, right? Replace back the a as a sine x. I got the sine x equals to -1 over 3 and sine x equals to 2. Again, for the sine x equals to 2, we can just ignore this equation, because we know that there will be no solution for this equation. Alright, and to solve this, I'm going to get my basic angle, which I get the arctangent of 1 over 3 first. It should be arcsine of 1 over 3, and I have it as a 19.47 degree. And sketch your diagram and locate your angle x by considering this sine. The sine is negative here, so when the sine x is negative, your angle should be at the 3rd quadrant or 4th quadrant. So just label your basic angle next to the x-axis. You have it as a 19.47. Okay, so now you can get your theta by measuring your angle starting from the positive x-axis. The first angle is 199.47, and the second angle, this is the second angle, which taking the 360 minus 19.4. So this is our solution. Since the second equation there will be no solution, we only have 2 angles to be accepted as the answer. This is the last example in the video. So I need to show the equation, this equation may be written in the form of tangent squared x, meaning that this is a quadratic form, and hence find the solution for x squared. X is from 180 to 180. So starting from the, I actually divide both sides by the cos square x, so that this you will get 2 sine over cos, sine x over cos x, and the second term here you will get 4, and here you will get 1 over cos square x, yeah, for the right side. So 2 sine over cos, it can be written as a tangent x, yeah, and then after that 1 over cos square, it can be written as a secant square x. And then the secant square, it can be written in terms of the tangent square, because there is an identity. Shows that the secant square x can be written as 1 plus tangent square x. So we try to arrange it nicely. we have a tangent square minus 2 tangent minus 3 equals to 0, which is this is what been asked by the question. Tangent square minus 2 tangent x minus 3. Yes, it's exactly the same. So we have shown that this statement, the equation, it can be written in this quadratic form. And now we're going to solve for this equation. Okay, to solve for this equation, I will represent the a as the tangent x. So my equation will become a square minus 2a minus 3 equals to 0. Then we try to factorize, and so here I have a tangent x equals to 3 and tangent x equals to negative 1 to be solved. For the tangent x equals to 3, get your basic angle, that is arctangent 3. I got the basic angle 71.57, and locate my x at the first quadrant and the third quadrant because the tangent taking the sign of positive. So my basic angle is over here, 71.57. And now you can get your theta. Okay, you can get, it's your x here. You can get your x by rotating your angle starting from the positive x-axis. The first angle is 71.57 and the second angle is exit 180. Since we only allow the axis from negative 180 to 180, so the second angle will be ignored. And now we use the we measure the angle, follow the clockwise direction. Okay, since we also allow the negative angle, so the negative angle, it should be negative 108.43. Alright, for the tangent x equals to negative 1, I also want to get the basic angle by finding the arctangent 1. Ignore the negative when you get the basic angle. That should be 45 degrees. And since your tangent taking the negative sign, so your angle should be at the second quadrant and the fourth quadrant. Okay, so the 45 degree will be over here. Now we can start to get your angle by measuring your angle. Follow the positive, starting from the positive x-axis to the first line. You get this as a 135. And the second angle will be exit 180, just ignore it. So now I measure to the other way around, that is follow the clockwise direction. I got negative 45 degree. Alright, so if I go further, that will be less than negative 180, which is already exceed our range. So this will be x. And then finally, I will just combine all of the angles together. So here I got 4 solutions. This